Next example that shows is 2x squared plus 9x minus 5 equals 0. So this is in the form ax squared plus bx plus c equals 0. It's already set up to 0, so I can graph my values for a, for b, and for c. Okay, so my value for a, that's 2. My value for b, that's 9. And my value for c is -5. So now I have to replace those values for the variables in my quadratic formula. That's -b plus minus square root of b squared minus 4ac, everything, the whole thing divided by 2a. So let me replace those letters for a parenthesis like I just did before. It's minus the square root of b squared minus 4ac divided by 2a. So I'm going to substitute my values for b. Where they go, the first two values, those are b always. -b plus minus square root of b squared. And the next value is going to be the values for a. Those are 2's, 2 and 2. And the last value is going to be the value for c. We are replacing. And now we have to do PEMDAS to this situation that we got. I'm going to distribute that negative sign, the first negative sign, that's going to be -9 plus minus the square root of, and then I'm going to do the exponent, that's 9 squared. 9 squared should be 81. And then you're multiplying -4 times +2 times -5. That is an even number of negatives. So even number of negatives, the result is always positive. So I know the result is going to be positive. Now I have to multiply the magnitudes. So 4 times 2, that's 8. And 8 times 5, that's 40. Multiplying the numbers. And then divide by, you can also multiply those two numbers in the bottom. So 2 times 2, it's going to be 4. The next operation that you have to do is the operation inside the root, as in PEMDAS. So you have to add 81 plus 40. Should be 121 divided by 4. Now at this point, this is where we have to define if this 121 has a square root of not or not. So we know that this 121, this is a perfect square. It's one of the perfect squares. It has a perfect square root. So in this case, we are going to take the root. This is the best way that we can simplify the expression. So I'm going to take the root in this case. We're not separating it into two roots because we do have the square root of 121. So we have to take it. That's -9 plus minus, and I'm not going to include the root sign anymore because I'm going to take the square root. So the square root of 121, that should be 11 divided by 4. This is like the first example. This is where I'm going to separate into two results because I can take it all the way to the whole number or the final number, final result. Okay, so let's start. Let's separate those into the two operations, the plus and the minus. So on the top, I'm going to do the plus. That's -9 plus 11 divided by 4. And on the bottom, I'm going to do the minus. So -9 minus 11 divided by 4. So let's see what two results I get from here. So -9 plus 11, the one on the top, -9 plus 11, that's going to be +2 divided by 4. And at this point, I have a fraction, and the only thing that I can do is try to simplify that fraction a little bit more. Right? You divide the top and the bottom by 2, and this is going to help you simplify that fraction. 1/2 is the first result that you're going to get, or the first solution for this quadratic equation. For the one in the bottom, we have to do -9 minus 11, that's going to be -20 divided by 4, and negative divided by a positive, that's going to be negative, and 20 divided by 4, that's going to be 5. So it looks like my two solutions, right, are going to be x equals 1/2 and x equals -5. So these are the two numbers that you're looking for, 1/2 and -5. Okay, or the other way around also, right? It makes no difference if you have it, if it shows in the PowerPoint as -5 and positive 1/2. Either or of these situations is correct. This is what we're looking for on this problem over here.